Hey everybody, this is Alex Merced, and you're listening to my tech podcast. And basically, what I want to talk about today is agentic AI. So the focus today is what I want to talk about is how to optimize agentic AI in the sense that, like, how do you build agentic AI applications and set up the things you need to set up to have better outcomes. Because a lot of times people will just rush to build AI or agentic AI applications, and the result is they realize there's all sorts of different bottlenecks. Like either they're not able to provide access to all their data in an efficient way to the application. This can result in it being more expensive, slower. It's not able to give good responses because it just doesn't have enough context around the data that it's working with. So essentially, how do you fix these things? How do you set your sort of data infrastructure in a way that's going to really enable agentic AI? And essentially, we want to address those three things: access to data, performant access to that data. So not only can it get the data, but it can get that data fast. And three, being able to access context to that data. So we'll talk about each of those three sort of individually, and kind of then I'll explain how some tools like Dremio can really sort of bring all three of those to the forefront in enabling your AI application. So first, let's talk about access to data. Okay, so oftentimes your data is not all in one place. You might have your data in lots of different places and controlled by lots of different people. So you may have data that you need that's in some other database, that's some other or data warehouse that some other department controls that they haven't given you access to. And then basically, if they do give you access, they don't want you to query that source directly. So they want you to then copy that data over to your system. And the result is you end up having all these copies of the data moving around. It's really hard to make sure that they all match. So then you end up having consistency issues where different people are saying different things because there's different versions of the data. It ends up being a little bit of a mess, making it hard for you to really get the value of AI because the AI can't give you sort of dependable answers when you prompt it. And of course, when I say AI, I'm really referring to sort of, large learning language models, more prompt-based sort of AI interactions versus sort of other types of applications of machine learning. So this is where a pattern called the data lakehouse becomes really, really important, because the idea is it's really hard to standardize in a sense that you could theoretically say, hey, let's all just use the same platform, standardize on something like a Redshift or a Snowflake or a Synapse. But there's a couple problems with that. One, putting all your data into one of these data warehouses can get really, really expensive really, really quick. Two, different departments are going to have their different preferences. Some people might prefer Redshift. Some people might prefer Snowflake. Some people might prefer Synapse. They might prefer Databricks. They might prefer whatever. So that becomes really, really difficult. Okay, and another approach you can say is, like, instead of standardizing on platform between different departments, how about we just say, hey, we have one team that then just handles that, so that way people don't have to worry about the platform. You have this centralized team, but then they become the bottleneck because then you have requests from across the enterprise coming to this one team to provide everything data-wise, to grant access to everything. That also becomes a bottleneck and becomes difficult to work with, because you're waiting a lot of time to get these responses when, especially in a world of AI applications, it's not just how fast you access the data, but how quickly you can actually build these things. So that's not ideal either. So in the lakehouse paradigm, instead of standardizing on tools or saying, hey, one central team has to do everything, you standardize on the way the data is stored. Okay, so essentially you're saying, okay, hey, we're going to store all the data on a data lake, meaning we're going to store it on object storage like S3 or ADLS or MinIO, Pure Storage, some sort of object storage or storage layer. We're going to store the data, specifically the structured data, okay, in Parquet files, and those Parquet files, which again will hold the data, we will be able to scan those files and identify which files belong to which data set, because we're going to have the metadata, and that's what's referred to as the table format. This is where Apache Iceberg comes in. Okay, so essentially each table is of the Apache Iceberg format, because you have this metadata that tells you, hey, these are the Parquet files that make up the data set, and that way a tool like Dremio or other query tools can then access that data intelligently. And then the last piece would be a catalog, something like an Apache Polaris, that can then identify, hey, these are the tables that exist. Here's who has access to them. So that way everyone can work with one catalog. Different teams can curate their data independently with whatever tools they like. They can all govern access independently, but they're doing it through sort of one central catalog. It's all stored in one place in a format that all these tools can talk to. Okay, so which would then enable much easier collaboration, because you're no longer having to physically move data. It's just then you're only really focusing on the granting of access piece. Okay, so that's the story there. Now, on that, so that's like the data access piece. Now, something like Dremio can then add to this, because at the end of the day, even if you move towards an Iceberg Lakehouse, you're probably not going to have 100% of your data in Iceberg. Not because you can't, you certainly can, but sometimes there's going to be small little data sources that are not worth building dedicated ETL pipelines for. Sometimes you're buying or borrowing data sets from other parties, so you're getting direct access to their databases and data warehouses, and you don't necessarily want to have to make a copy of their data because you want the freshest version of their data. So using a tool like Dremio, you can connect to these other sources along with your Iceberg Lakehouse and be able to then model all the different data sets your AI agents would need from one place. Okay, and this also adds an additional benefit of having this sort of one place to access all your data in security. Okay, Dremio in itself is a very secure platform, but on top of it is what would happen otherwise is you would have to create all this sort of connection code in your AI agent code. So you'd be connecting to this database and having to put all those different credentials in your environmental variables, and you have to make sure to keep those up to date, make sure that they're secure. And then again, if someone gets access to them, they get access to all these different layers of data. Okay, with Dremio, they would just have credentials to Dremio. They don't need credentials to every different data source. And then basically they would only have access to the data that particular set of credentials has access to via Dremio. So then what happens is that, again, if it gets compromised, the exposure is limited. They may be able to touch a data set in some Postgres database, but not every data set, just the ones that were granted access to by that set of credentials. And again, it just becomes a much easier story to manage. And then again, you can just decommission the token. So no longer those credentials can be used to access the data, and then just put in a new one much easier instead of having to go through every data source and have to recreate credentials in every different data source in the situation of a compromise. Because someone pushed their .env file over to their version control or something like that. So there's a security benefit too. So you get much more streamlined access to data, but much more secure access to that data. But the second layer is that performant access. Okay, what happens then is, like, even if you have access to all the data can be not fast to access. Okay, and the problem with that is then it just takes longer for the AI agent to come back with a response. And then when you talk about AI agents who go through several different iterations to solve a problem, this really can add to the time that it takes for an AI agent to complete a thing. So if it can complete those queries faster, it can then complete the series of prompts faster, and you can get an answer faster. So Dremio is specifically sort of really optimized for Apache Iceberg Lakehouses, in the sense that if your data is in Apache Iceberg tables, Dremio has features like a results cache, query planning cache. It can automatically optimize your Apache Iceberg tables, so that way they're always nice and sort of optimized for the basic underlying data files that will be rewritten to optimize them for better query processing, and that'll happen automatically. But the chef's kiss is a feature called autonomous reflections. Okay, where essentially, if you're familiar with how things like materialized views works and caching and all this stuff, it's essentially pulling from these types of ideas. I won't get into sort of the technical bits. I do have previous podcasts where I get into the technical bits of reflections. But in the past, you'd create these reflections. You'd choose when you want to use these things. And the problem is with Agentic AI, and this is the same thing with a lot of other platforms that have materialized views or even dynamic materialized views that automatically refresh. The problem is you still have to decide when to make these materialized views. And the problem is you don't know what queries your AI agent is submitting. Okay, you'd have to wait till after the fact. You would have to then audit. And it'd still be really hard to kind of identify a pattern, because your AI agent may be submitting different queries day to day. And so you'd have to be doing these kinds of auditing very regularly to kind of maintain this kind of optimization. The beauty of autonomous reflections is that it can automatically determine, or what it does, it'll daily analyze your query patterns and create the materializations and caching needed to accelerate those queries. So your AI agent will always be benefiting from acceleration of the queries that it's sending without human touch, in a much more sort of quicker cadence. So that way it can keep those agentic AI queries coming fast, at the same time as also enhancing any other queries coming into your data lakehouse. Okay, so again, we're addressing these three problems. So now we have access to all of our data for our AI agent. 2, we have performant access to that data for our AI agent so it can respond quicker. But the third piece is context. Okay, one thing is it has access to the data, but if it doesn't understand how the data is, or how you think about the data, it's going to give you really bad answers. And this is where suddenly a concept that's been around has suddenly become really important. This is the idea of a semantic layer. And essentially, a semantic layer is essentially a place where you define your data sets and you provide additional information about those data sets to provide context. In the past, a semantic layer has really been more for human consumption, okay, and also for consistent access and tools. So the idea is that you would define sort of the calculations for different data sets and essentially views on on your data, that then you can connect the different BI tools in a consistent way. So in the past, it was more sort of that way your business, your BI visualization, stuff like that would be consistent. You wouldn't recalculate monthly earnings 2 different times in 2 different ways. You would say, hey, this is the canonical calculation of this thing. So basically, whenever you connect whatever BI tool, you would connect to this. But it's not taking on a whole new meaning, in the sense that it provides additional context for your business. And Dremio has always had a built-in semantic layer, which is intrinsically tied to sort of how Dremio works. And it's not just being able to define views to have consistently defined metrics, but it's also a built-in wiki where you can define other contexts about your data set, okay, about how you use that data set, whatnot. And then 2, how, any context. And again, actually Dremio can actually AI generate these wiki entries and provide all that context in there. And then the sort of the final piece is, okay, right, you have a semantic layer, but you need to kind of combine all this stuff together. So now you could use other standalone semantic layers, okay, but then you have to kind of build in the integration. So you then have to build in the logic for your AI agent to, okay, go fetch the data, then go to your semantic layer and fetch sort of the context of that data, organize it all into a prompt, and then deliver it. Dremio makes this very easy. Okay, Dremio has an MCP server, and if you're not familiar with MCP, it's a standard protocol for creating sort of a modular agentic AI I like to think of it as a marketplace where you have all these different MCP servers, each of them kind of offering your agent a little bundle of powers, and then you can add those pieces to your agent or give access to these MCP servers to your agent to give it additional sort of abilities and capabilities and powers. But Dremio's MCP server basically not only allows your AI agent to send queries to Dremio, but it will also fetch the data from Dremio's semantic layer automatically. So in this case, you don't even have to think about the integration between a semantic layer and your queries. That comes out of the box with Dremio's MCP server. You would just connect your AI agent application to a Dremio MCP server for all of your data that's being accessible in one place, that it has its performance being managed by Dremio, and basically you will get really good responses because that semantic layer is going to provide additional context to your prompts. So in that case, you're going to get basically a lot of these sort of bottlenecks and creating sort of effective agentic AI use cases then become solved pretty quickly when you're using Dremio as the backbone for organizing a data lake house. So hopefully you guys found this useful. There's a lot of really cool stuff coming up. I'll be speaking at a lot of events. If you don't follow me on LinkedIn, please do. I'll talk about some of the events I'm going to be at very soon there. But I'll see you all later. Have a great day and enjoy.